Okay, yeah, it's that recursive thing. I can't actually avoid it, but anyway, it's just the fact that I'm sharing the screen and not looking at another screen at the moment. Yeah, in a sense, or more recursion. So, yes, indeed. I'll just double check that I'm recording, and then yes, I am, and then we'll get going. So, how have people found the material so far? We've really just been warming up, but in particular, yeah, C is a deceptively simple language. And what that means is that while it seems simple, in fact, that simplicity is a little bit deceptive. Yeah. So let's. So what I'm wanting to do this week is give you the core skills that you need to work on your assignment. So what I'll do actually is sometime this week I'll actually make as well a walkthrough video where just explaining the various parts of the assignment. There's already the spec and that kind of thing. Okay, is everyone else okay with audio or no? Okay, so it might be your bandwidth. Yeah. I'm not sure if you can actually change your settings for that. Let's just see. There's not a lot of things here. Yeah. We might just have to kind of muddle through with it. If it's only some of you, then it's probably at your end. There might be other things running on your machine, on your network. Other people using the network, the speed of your connection, that kind of thing. Yeah, might be something we need to solve as we go along. Sorry I can't be more help, because if it was everybody, then it'd be something at my end. But if it's only some of you, then it's your connections. Hangouts doesn't have huge amounts of settings. Yeah. Yeah. So I think we'll just muddle through. And we'll yeah. Okay. So yeah, definitely we want to set the scene this week for your assignment. And for that, because of that, we're going to spend most of our time talking about arrays and that kind of thing. But before we get there, I wanted to actually remind you of some things. Yeah. So, just remind you of some places that you can get help. while you're going through this course. This document here, frequently asked questions, so things which relate to common problems that people have had in the past. So I really encourage you to familiarise yourself with it. A lot of the questions there are things which will arise for you as you go along. Okay, Ricardo, that sounds like a sound setting, not a network issue. So you might want to make sure you've got the right sound cards selected and all of that kind of thing. Well, I don't mind what you use as a resource so long as what you submit complies with what I ask of you. So, and that kind of means, well, I haven't reviewed the resources available on Lynda. This is a course where we're going to teach ANSI because it's portable. And yeah, well, I recommend trying things out for yourselves, figuring things out, doing lots of exercises, and using the stuff I provide as a starting point, I reckon. Yeah. Well, if you need extra resources, feel free to look around, but you have to know what to reject, because there's an awful lot of confusion out there between various versions of C, and there's also confusion between, say, C and C++. And any resources that don't make those clear distinctions are going to be a disadvantage for you rather than an advantage. So that basically, if you find stuff out there which conflicts with what we're saying, I want you to bring it to me and I'll tell you what I think of it. I think that's probably the best thing to do. But in particular, there's a range of things which we tell you not to use, so don't use any of those. And I think you'll find that a lot of online materials will use things which I kind of discourage you to use. So be aware of that. Okay. As well as these frequently asked questions, I have an online version of the course notes. So I'll just actually show you this fella here. Okay, so there's various things here, like for example, if you're wondering why particular C is working in a particular way, there might actually be a thing here, and I'm more than happy if you feel that you come across something that you'd like to be added here, just tell me and I'll do it. Well, I'll do it if I agree with you, but it might just be a case of me going, no, you're wrong, and this is why. Okay, so there's that one. And now going back to my slide, this bottom one. Yep. So this is basically material for, it doesn't quite match up exactly with the weekly materials, but it's kind of more or less around the same place, and it gives you some resources on arrays and strings and all of that kind of stuff. I just might make it a bit bigger so that it actually comes out better on the recording. Yeah, like so. There may be some mistakes here, and if there are, feel free to let me know, and I'll fix it. That's why I have it on my I have this on sites, on Google Sites, is so that I've got edit rights here. So anything which is not correct, please have a look at. Yeah. Yeah, maybe this is just like a week ahead. Oh, it's slightly out of sync. But it should be helpful. Okay. Radio. Also, I have examples which are in my shared space on Titan, Jupiter, Saturn, in, fun enough, shared examples. So this is things like input, output, and all that, which is probably something you'd be quite interested in now. Arrays, linked lists, lots of things which we'll be covering later in the course. The information's there. And clearly, from my point of view, one of the most important things you're going to come across is, in fact, the tutorial and lab exercises. They are the core of the learning. That is, you learn by doing it. So that's really my perspective on all of it. Okay? So please use these resources. I've put them together. Well, I've put them together, and it's based on previous people's work over probably a decade or more. Yeah. Okay. So any questions about those places to look for help? Clearly there's things like the discussion boards and that kind of thing as well. Actually, discussion boards for any questions about the course, they're your first place to go. Because anything which I answer there is going to be something that I'll refer other people to. And in fact, clarifications made there apply to the assignment. So you want to keep up to date with what's there. Okay. So we're going to spend a bit of time today on pointers. Now, I don't want people to get hung up on pointers. Pointers is just a special data type that represents a memory address. And it could hold, and by the type of the pointer, we know what it holds. For example, an int star pint. Pint is a memory address that holds an int. Right? Now, we can also have int star pp int. Now, here, pp int is a pointer to a location in memory. and that other location in memory holds an int. So if you want to see it, basically we have, yeah, don't really have drawing tools here, but we essentially have a pointer to an int. And we can go on and on and on with this as much as we want. Right? Now, char star PA, is that the declaration of a string? I'm glad you asked, Bradley. We will be covering an example this very week. In fact, later on in the chat. It's very correct. But even then, a char array is not a string. It's getting closer, but it's not quite one. We'll have a look at why in a little bit. But notice this. And Ben has actually mentioned exactly why. A char array is an array of char which is null terminated. That is, the ASCII 0 is at the end. But watch this, right? I have char star PA star PB, comma CH. Is CH a pointer? No, it's not. It's an ordinary run-of-the-mill char. But you see how these pointers can actually really mislead the eye a bit. So I recommend, as much as possible, don't use pointer syntax unless the thing you have is really a pointer. If what you're after is an array, use array syntax. It's much easier to read. Okay, so we'll start off with the simplest ideas in terms of pointers. So, int I. What's in I? We don't know. It hasn't been initialized. But pint, we assign to pint the address of I, which means pint points to I. And then we have pint, and that points to pint. So once it's initialized, we can now set the contents of I through the pointer. See how really here, and one thing which often people get confused by is what is the relationship between the ampersand and the star? Anyone want to have a go at answering that? What is the relationship between the ampersand and the star? Yes, Ben is correct. Ampersand, we take a memory address. Star, we get the value inside the memory address. Okay? Now, the truth of the matter is that you've programmed in other languages and there really are pointers there even if they say there aren't. Every time you've used a object in Java, you use new, which means that you're actually getting a pointer to the object. We'll get more into that allocation stuff later, But to answer Aaron's question, this is one way to initialize a pointer. A pointer must be initialized before you use it, just like any other variable must be initialized before you use it. Just think about it as a special number. It's a number which is a memory address, which means we can do things on there like tell me the contents of that location referred to by this pointer using star. We can even assign to the contents as we have here. So an uninitialized variable is wild card. We don't know what is in it. We don't know what's in this either until we initialize it. Because we don't know where it points. And remember I went through that bad printf example? We can actually understand why this is a problem a bit more. No. We don't know where it points. It's uninitialized. That would be true for global variables. Global variables are default initialized to 0, but local variables are not. So we can see now here that because we know it expects a char star, and what it actually converts that int to a pointer and tries to dereference the value in memory address 3, almost guaranteed to not be one that you have a right to access. Yeah, never assume anything is initialized unless you've explicitly done it. So let's have a look at some things we can do with a pointer. Have any of you come across iterators before in another language? Well, we can use a pointer as an iterator over an array, right? Like here, int star pr equals r. We can assign, because here a very special quality about arrays is going on. An array is a pointer to the first element of the array. It's a constant pointer. We can't assign to an array. We can assign to the elements of an array, but we can't assign to the array. We can't increment an array. So here, PR is essentially an iterator. When I do PR++, like it starts off pointing to the 1 after this assignment. After I do PR++, PR++ now points to the 2. Right? And I could do PR square bracket 0 and it would give me 2. If I did PR square bracket 1, what would that give me, do you think? Correct. Because array syntax is simply a more easy to use syntax, but it's still pointers. So PR1 is the same as star, hang on, let's get this right, put the star on the outside, they are exactly the same. Which one do you prefer? Yes. And in fact, the first one, they both mean the same thing. They'll even generate the same code once compiled. There is no advantage in the pointer syntax, unless we need to be doing many pointer operations. I want you to learn the pointer syntax so that you can read it. But I discourage you from using pointer syntax in your code when array syntax is what you need. Because array syntax is much easier to read. I mean, you should be able to read both. It's just pointer syntax, it results in more errors in your code. Now, we can use, so as well as incrementing, we can also decrement, so we can use minus minus to go, and notice something. How much bigger does pint get when I increment it? Correct. It's an int. Correct. It's the size of what's being pointed to. So we jump ahead by an int each time. We don't need to add that into our calculations. It's done for us. Likewise, minus minus will allow us to go backwards by 1. And pint plus equals 3, jump ahead by 3 ints. Yes, but we get greater freedom. Potentially seg faults. So it's your responsibility. Well, you need to know how far along things are. There is no bounds checking in C. Purely an array operation is a pointer addition. Tell me something. Is this also a pointer? Yes, we've just jumped ahead by 3 elements. Now that wouldn't be valid with this array because there's only 3 elements in total, which means that pint actually points beyond the end of the array. Well, plus equals would change pint. Because An array is a pointer. It's a pointer to the first element of the array. Well, it's the same as the address of PR I plus 3, so because there is no dereference. Now, we can assign a pointer to an array, but we cannot assign an array, we cannot do R equals PR. No! Why not? You should try this in your code. Don't take my word for it. What's more than the fact it's already an address, an array. Let's go back to our definition of an array name. An array name is a constant pointer to the first element of the array. So if we assigned some other pointer to R, was our array gone? It's disappeared. So an array owns the memory that we allocate it from an array declaration. Here, when we use assignment, here, what we really mean is copy this stuff in. It's an initialization. That's correct, Brad? Yeah. So we actually copy 1, 2, 3 into the memory which has been allocated for R. And we can't do this any time after declaration, because then it's an assignment, and assignment works differently. And assignment is literal. This is that. They are the same thing, is what assignment means. In Java, you could sometimes use the equal sign to mean copy this in. In C, it's always assign. It means this is that. Okay. It gets a little bit more complicated than that, but that's the main idea. Now, we can use comparison operators, but what they mean is if A is less than B, and they are both pointers, then A is earlier in memory. That's all. And that's almost never useful. There might be some times when it's useful, but almost always, I mean, I haven't really come across any useful use for comparison operators with pointers, except perhaps this one, the double equal sign. So are these the same memory address? That's useful. But less than or equal to, greater than, it's place in memory. Not useful. You almost always want to be comparing their contents, not the pointers themselves. Okay, so that's our really quick and dirty introduction to pointers. Any questions so far? Okay. So we're now going to have a look at functions. That's correct, David. In the second half of the course, we'll look at dynamic memory allocation because it's more complicated. But for now, arrays are fixed size. And that's going to simplify a lot of what you do in your assignment. Never fear, we will be looking at dynamic arrays in assignment 2, or in assignment 2 part 2, because assignment 2 has 2 parts. But yeah, so let's talk about functions. So a function has a return type, a name, and a parameter list. So each parameter has a type. So, for example, we've seen, yes, main should call other functions, and it's my view that a function should be at the most 1 screen in length. So 25 lines. And that your function calls simply, they read off like an algorithm, like the steps in a recipe. And then the functions that do the work should each do one thing. That's my general approach to functions. So here we go. We have main. With specified void, which means it takes no arguments. Okay. So, but that could be many other functions too. So we talk about pass by reference, we talk about dereferencing, all this kind of thing. The truth of the matter is that everything is passed by value, including pointers. So we pass in the value of a pointer, which means that lets us change what it points to. Change the value of what is pointed to. So I'll just very quickly show you swap. And where is that fella? He's over here. Just connect to the server. Well, a pointer is valid so long as what it points to is valid. And I'll talk about that a little bit more in just a moment. Okay. And let's say we'll have a look at it might be week 2. No, that's weird. Okay. No. Okay. Well, let me just quickly write it anyway. It won't take a... Yes, definitely. In fact, you'll need to do that in the assignment. So, say for example, int a equals 3, b equals 5, right? So let's do now. This is one of the few times when I think that temp is fine, because it really is a temporary variable. So what's wrong with this? And the reason why, correct? Right. So the problem is well, the thing is, in fact, everything is passed by values, in fact. Because, yes, we make a local copy, right? When we pass things into a function, we make a local copy, right? So we have a local copy of A and a local copy of B, separate memory location, right? Then we swap those values in memory, but in fact in the local function, but they are a different A and B to the ones down here in main. No. So, hang on. Temp equals A. Now, B is copied. A is copied into B. I see. That should be B actually. My bad. So we capture the value in B, then we assign A to B, and A gets the value from B. So let's change this. I'll actually make that int star A star B. And then what we do down here is we pass in the addresses. Right? And what we should see as output is 5, 3. Should be the output. Because we start off with 3, 5. Yes, because you got a different type. Well, that's a matter of preference. I like to keep the star normally next to the variable because A is in fact a pointer to int. So the pointer part I see as being attached to the variable. Right? So now yep. Okay. Aha! In here, we need to dereference every time because these are now pointers, right? Right? No, we need to dereference so we can actually get to the contents. That was the issue. Okay. Now, this relates to your assignment, by the way, as everything does. What if I want to swap pointers? That's what the swap players function that you have to write for your assignment is all about. Is in fact, take this idea of swapping. Yeah, it's actually once you understand it, really easy, but most people struggle with it. Yeah. Which is why I have it in the assignment. Yeah, because you'll understand pointers so much more once you've understood that. Okay? And have a look at the counter.c example. I'm running out of time, so I'm not going to look at it here. But it's an example of a module. That is a C and a .h pair that actually perform some function. In this case, they are... Oh, I think I really should go through them, actually. Very quickly. Okay. You notice we have a variable count, but we don't initialize it. But we pass it into this function, counter. So let's have a look. So here I have an example of a function prototype. which we'll get into those in just a moment. That's a declaration that this function will exist later. And it takes in an unsigned pointer. And then here, static. Anyone know what static means? Well, it's not constant, no. Yes, it lives between function calls. It still exists between function calls. Yeah. Actually, Ben's correct in terms of its meaning, in terms of memory, yeah. It's actually, it exists in the same place as global, but it's only visible locally. Right? So, I assign here the value to the pointer which was passed in. Right? And that's all we do. And that counter it simply does counting, but the counting itself doesn't happen in main. The variable exists in main, but we pass it in to counter by reference. Well, we pass in the address of it. Okay? Does that make sense? Okay. I know that I'm going through a lot of concepts which might you might not be familiar with, but we've got to get through them. So, okay, function prototypes. Function, now, the way it works is that the C compiler parses a C file starting at the top, and it goes sequentially through the entire file till it reaches the end. What that means is that C needs to know about things before they're used. It needs to know, for example, if you're going to call a function, what its type is, what its name is, and what are the type and number of its parameters. We must know this before we get to it. If the compiler doesn't know about that function yet, it invents a prototype for it. And so if you see an implicit declaration of a function, has anyone seen that yet? Implicit declaration of function. That means it doesn't know about that function. It doesn't know what its return type is and its parameters. Now the problem is that that the compiler makes some assumptions. There are assumptions it is allowed to make under the ANSI standard. It is allowed to assume that the function returns an int. Why could that be a problem? Correct. And in fact, you might get another warning later on when you assign the return value to a pointer, because assignment of pointer to int without a cast will be another warning you get because of that. So that all of these things were solved when ANSI brought in the idea of a function prototype. So just like, if you remember here, we said you can expect a function called counter, and you can expect it to take a single argument of type unsigned pointer, and you can expect that it will return nothing. This is what I've said to the compiler in this declaration. Is that clear? And so that's why in counter.c we hash include counterlib.h, because all we need to know is that there will be this function somewhere. At the time of compiling this individual file, I don't need to know the implementation, I need to know its prototype so that I can use it correctly. Okay? And sometimes you might get implicit declarations of functions you're expecting to exist. Either you haven't hash included the header file, or it's not an ANSI function. Because the default for ANSI is to reject any functions. Well, the pedantic flag says reject any functions that are not part of the standard and that aren't part of this project. Okay. Now, we have a type def as a type in C. Basically, it's an alias. And you will notice that I've used type def in your assignment. The game board is in fact in cell contents that's the type of the game board. But what I've done is I've type defed. So if we just bring all that back down, no, it's not going to let me. Okay. No. Okay. So if you have a look in the startup code, there's basically a type def which renames gameboard to be an array. Actually, height and width are around the other way, because height should be the first element, not the second in the array. And that has to do with the order in which the elements get processed. So that we actually can iterate over the array faster because the elements are next to each other. And this property of having things next to each other is important. You'll see I return to it a number of times. Just like here, I've renamed int to schar. Now, it doesn't mean I can no longer use the int type. It just means if I use schar, the C compiler will go, oh, you mean int? Yeah, no worries. But sometimes renaming the type might make it more meaningful. Sometimes it makes it less meaningful. So I would use type defs to a limited extent. I've used them, for example, where actually something I defined over here in one bit of code, I want to reuse over here and give it a different meaning. Then I've used a type def. So I'm reusing the type, but for a different purpose. So an example of that is color. Because I actually type def in cell contents to color. And then I can use the type color to specify the type. Boolean is another one. I've tried to keep them to a minimum, but so you get and scoreboard. Things which I think create more meaning through the type def. That's what I've tried to do. And I'm sure it will create some confusion, but I think that I want you to go through that confusion a little bit as well, so you understand the confusion other people have when you type def things. And whether or not it makes the code more readable or less readable is something I want you to think about. Okay. So an array is a series of contiguous memory locations. That's all. That hold some type. Now an array size is the size of the type it holds times the number of cells. So as I've mentioned before, it's simply a constant pointer which points to the first cell of the array. But otherwise, you can use arrays and a pointer to an array as the same thing, except you can't assign to the array itself. You can assign to the elements of the array. Something which confuses the hell out of people, and therefore is something I want you to think about, is size. So we have an enumeration of the sides of a dice, right? And I have a struct called stuff, which has double, double, double. It doesn't matter what we renamed the thing to. Its size is the size of the thing that we renamed it from. So size of double times 3. So stuff, how big should stuff be then, do you reckon? Size of what? Eight. Size of double by 3. So yes. Now double is 8 bytes. So stuff should be 24 bytes. Okay. So I have a dice with a number of sides. So sides being 6, so a 6-sided dice, right. Then I have a dice pointer that I assign dice to. Is size of dice pointer going to be the same as size of dice? Correct. So dice pointer will be the size of a pointer on that architecture, 8 bytes. Whereas size of dice is 6 times the size of enum side. Now side is 4 bytes each because they're ints. Well, we're talking about on this architecture here, 64-bit architecture, each one of these is 4 bytes. So 6 4s are 24, right? And see, I can have the side and you'll see also that Boolean, how did I define Boolean? Well, it's an enumeration, which means it's the size of an int. Okay? One question. How big... So there's two things here, right? What if I just did this? How big's that? Size of dice. Well, it's a pointer. So it's the size of a pointer. Right. What if I do this? Does that change anything? Well, it changes the syntax. But actually, no. It doesn't make it an array. A single dimension array, when passed as a parameter to a function, degrades to a pointer. Even if I do so, I've said all this, but let me prove it to you by actually running the program. We pass the address of the first element of the array. That is, the array name is a pointer to the first element of the array. Okay, total size of the dice is 24. Yep. So there we're using the array. So there's an implicit multiplication of size of dice side times num sides. When we're in the function in which it was declared. Size of a side, 4 bytes because it's an enum. Size of dice pointer, 8 bytes because it's a pointer. Size of dice from function, 8 bytes. But let's just change that very quickly. Let's make it size of star dice. How will that change it? It's the size of the first element of the array. So we know that's 4 bytes. So now we should get from the function 4 bytes. Times the number of sites. So now we should get the correct number. 6 times 4 is 24. And there we get it, 24. So I provide you these functions so you can play with them. Actually understand how arrays and pointers work. Okay. So here we've got a one-dimensional array. But we can actually write outside no. Multiplication of pointers makes no sense. You can multiplication of pointers by pointers makes no sense. So that's never going to happen. Oh, hang on. Wait a minute. No. The thing here, though, is we're dereferencing P times the dereference of P. So that does make sense. But how readable is that? Maybe what you want to do is in fact have a separate variable and then do kind of assign that to that variable and then do, say, call it Q, and then have Q times Q. Yeah, it's still pretty ugly though. So, but here's the thing, is that when you write out, so you see, we allocated 5 elements, which means the array is 0 to 4, right? But we never, so let's think about what we do here. Table 2 is 3.24. Yep, table 2. Table I, so I is 1. So table 1 is table 2 plus 1. Yeah, 3.24. Table I plus j. So I being 1 and j, so that means 3 is 18. But check this out, table minus I. So currently I is 1, so this means table 0 equals table j minus 2. Okay, that's weird. Table I minus equals table j. So table j is 2. Minus 2 gives us 1.24. But here's the thing. Table minus I. So now I is minus 1 equals 2.3. Yeah, well, normally, remember that a array notation is just pointer notation. So for all we know, for example, if I made that, say, my table, is that okay? It is, because my table starts here. So my table 0 is table 1. So my table -1 is table 0. Because it's simply pointer arithmetic. So once you've declared your array, the only thing you cannot do with your array is assign to it. But in every other way, it's just a pointer. And so any syntax which is valid for an array is valid for a pointer. And its meaning is relative to its starting point. And think about it this way. This is an array. This is a subarray of table. So is this. So is this. So I can pass into a function the address of so I can pass into a function table +2. Now that's now a new array that starts here, where this is the 0th element of that new array. This is the 1st and the 2nd elements of that array. So array indexes are relative. They are pointer addition and subtraction. And that's why there's no bounce checking. Well, you can actually turn it on with some libraries and so on. And I'll show you how to do that later in the course. Okay. So, I know, mind blown for a lot of people. But, so, now 2D arrays are essentially an array of arrays. And actually, the way this person has written this loop is inefficient. Because it means that we're going down one row, then we're going down the next row, then down the next row, which means we are we're not accessing memory in the expected order. If you swapped J and I here, it would actually be, the code would run a lot faster. So there's a mapping between the C declarations and the actual layout in memory. So when we pass a multi-dimensional array, it doesn't degrade to a pointer to a pointer. An array of arrays and a pointer to a pointer are two different types. The first dimension becomes a pointer. but the other dimensions need to be kept. And the reason why is because then the machine knows how far ahead in the array do I need to jump to get to the next dimension. So it's actually a jump in memory. So I'll just very quickly show you. So I have a matrix which is quite simply an array of arrays. And see how currently I don't have that second dimension specified? I'll need to, because it needs to know how big the second dimension is. So we'll fix that. So now if I try and compile that, line 35. Okay. Okay. And I'll just quickly take you through the code. All I do is I define a matrix with some numbers, and that's my array, and another matrix, and then I define a function matrix sum, which just adds together the elements in each row and column and puts them in this third array, this third 2D array. That's all it does. You notice that I don't need to specify that first element, but I need to specify the second one because the machine needs to know how far ahead I need to jump in memory to get to the second dimension. It's not readability, it's actually got to do with size definitions. The compiler needs that information, or else it's meaningless. Okay. Let's see how we're going. We're running out of time. Oh, we have run out of time. Let's just see. Okay, just give me a few minutes and I'll quickly go through what we got left. So, here, you see we've got this arrow, right? So you know previously we've used a dot to be able to access an element of a struct, right? Pretty much like we use a dot in Java to access an element of an object. But when we have pointers to objects, we need to use this arrow instead. And that arrow means the same as dereferencing the pointer, then dot and access the element we need. You can see how the arrow is actually much more readable than the dot. Less typing too. Less opportunity for mistakes. Given that array parameters are actually pointers, is there any way we can actually and when you pass a pointer into a function, you allow that function to change what's there. Is there any way we can stop a function from changing the contents of that array? We have the const keyword. And that means that any function we pass a const array into can't change the contents of that array. It means like read only. Okay, almost done. So here we get to the fact that a char array like this, hello, is not a string. It is not null terminated. It has no 0 byte at the end. Whereas a string has a 0 byte at the end. And that means you can rely on any C functions which talk about strings. You can rely on the fact that there is going to be a 0 byte at the end, that they will be null terminated. And so here we have two declarations of a string. Char star p equals abc and char s square brackets equals abc. There is a subtle difference. P is a read-only string. Why do you think it's read-only? I haven't said const here, but it's read-only. It's actually a pointer to the place in the binary where this string appears. Yes, there is a char array buffer that reads stuff in. The second actually copies ABC into S. So the compiler says, oh, ABC, that's 4 bytes. So S will be 4 bytes long because of the null terminator. Okay, so in our chat tomorrow, we're going to talk a bit about fgetS. fgetS is really important and awesome. So probably before you come to the chat tomorrow, if you get a chance, have a look at the read rest of line example. Have a look at scanf int and scanf string, because after this week scanf will be sent to the dungeon. We're not going to let you use it anymore. We want you to use fgetS, and we'll talk more concretely tomorrow about how to use fgetS. That's really probably the bulk of what we'll do tomorrow. So A to I. A to I accepts a char pointer as an argument. If the string is invalid, it returns 0. What's the problem? If a string does not contain a number, returns 0. What's the problem? Correct. And quite frankly, most of the code I see with A to I in it is really lazy code, and it's just not robust. And in fact, it will be immediately after this chat. I'll actually add the invite. So I've had lots of things going on. So A to I actually calls string to long to do the work of parsing the string. So it's not only less safe, it's slower. Because, you know, when you do a function call, you copy each parameter onto the stack, you copy the return address, and you jump somewhere else in memory. And you've got an additional cycle of doing that with A to I, which just isn't necessary if you're using string to long. So I will penalize people for using A to I, because I think it's just laziness. And also string to long is a good opportunity to learn more about pointers to pointers. So yeah, and I'm not going to talk about this now because I'll talk about it tomorrow and in a lot more depth. But you can see here we have a pointer to a pointer. So we can pass in the address of a pointer and then change that inside this function. That's the real power there, is this parameter here. Okay. ctype.h, really quite handy. It has lots of functions for validating characters. So is this character a digit? Is this character an alphabetic character? Is it alphanumeric? Is it lowercase? Is it uppercase? Is it a space? It has functions as well to convert to lower and to upper and all this kind of stuff. Really recommend, although I don't think I'll require it. You might want to use it in the assignment. It's up to you. Now, I could have had lots of slides. MIDI, you mean as in MIDI music? It's just a really, well, that's just a file type that has a kind of an object-oriented structure. I played around with it a bit, but yeah. So I'd encourage you to explore this. Type into the terminal apropos string and it will come up with a list, and you might need to filter that for the ones which are C functions and not in some other language. But certainly ones to look at are things like strcpy, strlen, strcat, strtolong, strtoc, and we'll be dealing with them tomorrow. So I guess the bottom line is learn how to use the documentation you're provided with. So for example, you learn how to use the man page for a function, and I'll actually be talking about, I'll actually use the man page for fgetS to help us to figure out how fgetS works tomorrow. Okay, so we ended up running a little bit over time, but any questions? I think you'll find this particular week's material is critical for the assignment. Understanding this material, then you can really get stuck into the assignment. Yeah. Okay. So if you can't make it to the chat tomorrow, at least watch the recording, follow along with the exercises and that kind of thing. Would it not let you join? Oh. I wasn't aware of that problem. Okay. So I'll actually investigate some other options then in terms of yeah. Yeah, because that's not fair on you. I'm sorry, I didn't realise that. I didn't realise it was so little. I'll investigate other options and then I'll get back to you. For tomorrow, we'll still use Google Hangouts, but I'll see what other options for larger chat numbers. I'm not familiar with Twitch. I'm happy to try it, but give me a few days and I'll come up with an option. Yeah, I just didn't know. The problem with that is it's a real bandwidth hog. It's actually more bandwidth than I have. Yeah. So, okay. I'll investigate some options and then I'll come back to you with a workable option. Okay.